Hey all, this is Nish. Welcome to another video, or a presentation I should say. Sorry for the background noises. It's quarantine season, but people are still going out. Anyways, today we will be talking about energy. I know it's a vast topic, but I have narrowed it down to a few subtopics. So let's see how it goes. Well, before I start, I would like to ask you guys a riddle or something like a joke. So are you ready? My question is, what is the wind's favorite color? To know the answer, please do stick to the very end of the video. It would be highly appreciated. So, before we begin, let's go through the contents of this presentation today. So, we will be talking about energy and its types, renewable and non-renewable energy and its examples, energy density and specific energy density, coal-generated electricity, other methods used to generate electricity like the PHS, which will be discussed further down in the presentation, and Sankey diagrams and scenarios. So, what is energy? Energy is a word which tends to be used a lot in everyday life. Usually, it does have a very specific physical meaning. Energy is a measurement of the ability of something to do work. It is not a material substance. Energy can be stored and measured in many forms. All forms of energy are associated with motion. For example, any given body has kinetic energy if it is in motion. A tension device such as a bow or a spring, though at rest, has the potential for creating motion. It contains potential energy because of its configuration. Similarly, nuclear energy is potential energy because it results from the configuration of subatomic particles in the nucleus of an atom. Energy can be neither created nor destroyed, but only changed from one form to another. This principle is known as the conservation of energy, or the first law of thermodynamics. Energy can be converted from one form to another in various other ways. For example, usable mechanical or electrical energy is, for instance, produced by many kinds of devices, including fuel-burning heat, engines, generators, battery, fuel cells, and magneto-hydrodynamic systems. To dig further into this topic, we will be mostly talking about energy that comes from the natural resources or elements found on Earth and around. So, what are the primary sources of energy? Primary sources can be used directly as they appear in the natural environment. Coal, oil, natural gas, wood, nuclear fuels, uranium, the sun, the wind, tides, mountain lakes, and the rivers from which hydroelectric energy can be obtained, and the earth heat that supplies geothermal energy can all be used as the primary sources of energy. So, what is renewable and non-renewable energy? And what is the difference between renewable and non-renewable sources of energy? A renewable resource is a natural resource which will replenish to replace the portion depleted by usage and consumption either through natural reproduction or other reoccurring processes in a finite amount of time in a human time scale. Examples include food, water, air, and biofuels. A non-renewable resource, also called a finite resource, is a natural resource that cannot be readily replaced by natural means at a quick enough pace to keep up with the consumption. An example is carbon-based fossil fuels. In metallurgy, fossil fuels, coals, petroleum, natural gas, and groundwater in certain aquifers are all considered non-renewable resources, though individual elements are always conserved, except in nuclear reactions. Moving on, what are the energy densities and specific energy densities of these primary sources of energy? But first, let's get to know what these densities are. Energy density is the amount of energy stored in a given system or region of space per unit volume. Often only the useful or extractable energy is measured, which is to say that inaccessible energy, such as rest mass energy, is ignored. In cosmological and other general contexts, however, the energy densities are considered are those that correspond to the elements of the stress energy tensor and therefore do include mass energy as well as the energy densities associated with the pressures. Whereas specific energy density is similar to energy density, but the only difference is that it is the energy per unit mass. Moving on, we will see some energy densities of primary sources. As you can see, this table shows some of the energy densities of primary sources. We have wood, coal, ethanol, biodiesel, crude oil, gasoline, natural gas, and uranium-235. I also forgot to mention earlier, but there is the energy density SI units and SI base units and derivations from the other quantities given in the previous slide. Please do check it out. Now let's see how electricity is generated from primary sources, in this case coal. So some of these elements like coal and fossil fuels are used to make electricity. Fossil fuels consist of deposits of once living organisms. The organic matter takes centuries to form. Fossil fuels principally consist of carbon and hydrogen bonds. There are three types of fossil fuels which can be used for energy provision: coal, oil, and natural gas. Coal in this case is a solid fossil fuel formed over millions of years by decay of land vegetation. When layers are compacted and heated over time, deposits are turned into coal. Coal is quite abundant compared to the other two fossil fuels. Furthermore, let's see how electricity is actually generated from coal. So, energy gained from burning fossil fuels is converted to electricity and heat in commercial power plants. When fossil fuels are burned, carbon and hydrogen react with oxygen in air to carbon dioxide and water. During this reaction, heat is released, which further amplifies the reaction. Electricity is generated by transforming mechanical energy, which is heat, to electrical energy in a turbine or a generator. Generating electricity has its own advantages and has its own disadvantages. Power plants are very expensive to build first of all, but once they are present, efficiency in converting fuel to energy is very high. Most of the time, more electricity is created than is actually needed, because electricity cannot be stored. Electricity demands vary throughout the year, and as a provision must meet the peak load, which means the highest possible demand within a year. If the demand significantly exceeds a power plant's capacity to generate electricity or energy, this may cause temporary blackouts or breakdowns. Burning fossil fuels is responsible for environmental issues that are high on the political agenda these days. Examples are greenhouse gases accumulation, acidification, air pollution, water pollution, damage to the land surface and ground level ozone. These environmental problems are caused by release of pollutants that are naturally present in fossil fuel structures such as sulfur and nitrogen. Coal may result in underground fires that are virtually impossible to extinguish. Coal dust can also even explode. This makes coal mining a very dangerous profession to be in. There are various other methods to generate electricity. One such method is PSH, which is pumped storage hydroelectricity, or PHES, which is pumped hydroelectric energy storage. This is a type of hydroelectric energy storage used by electric power systems for loading balance. The method stores energy in the form of gravitational potential energy of water, pumped from a lower elevation reservoir to a higher elevation. Low cost surplus off peak electric power is typically used to run the pumps. During periods of high electrical demand, the stored water is released through turbines to produce electric power. Pump storage hydroelectricity allows energy from intermittent sources such as solar, wind, and other renewable sources, or excess electricity from continuous base load sources such as coal or nuclear resources to be saved for periods of higher demand. The reservoirs used with pump storage are quite small, and when compared to conventional hydroelectric dams of similar power capacity and generating periods are often less than half a day. Now, these companies, in order to maintain profit levels as well as thinking about how much output can be produced due to a certain amount of input, companies need to calculate everything properly and accurately. They can do this by making use of Sankey diagrams, which will be explained further in the next slide. So, what are Sankey diagrams? Sankey diagrams feature directed arrows that have a width proportional to the flow quantity visualized. If a flow is twice as wide, it represents double the quantity. Flows in a diagram can show, example, energy, materials, water, or even costs. Within a Sankey diagram, the directed flow is always drawn between at least two nodes or processes. Thus, it shows not only flow values but also information about the structure and distribution of the defined systems. So they are a great alternative to common flow or bar charts or even pie charts. They are gaining popularity in energy management, facility management, process engineering, process control, and many other kinds of data visualization. Now we will see how Sankey diagrams are used in real-life scenarios or situations. This example talks about food supply chain. Now in this rather simple chart, you can see losses along a process chain for food. In every step, the losses are shown as an arrow branching out to the bottom, labeled with percentages. These percentages show mass percentage. So here we have no absolute quantities, although the diagram is based on real data, but we only have proportions. One could call this the efficiency of food production, processing, and consumptions. To conclude my presentation, I would like to have a chat or talk with all of you. So you have probably heard the hype about going green and saving energy. The green movement seems to have taken over the world, empowering eco-friendly people every day. If you are not into the hype about the green energy industry yet, read on to discover why you should have to save energy. There are a number of reasons why you should consider cutting back on energy consumption. First of all, reducing energy use limits the number of carbon emissions in the environment. Carbon emissions play a significant role in the climate change. It is thought to be the cause of powerful natural disasters in recent years. With billions of harmful emissions in the atmosphere, cutting back is always a good thing. In turn, conserving energy produces a higher quality of life. Reduced emissions result in a cleaner air quality. In addition, it helps create a healthier planet, or at least helps sustain the resource we already have. Being conservative with energy can ensure that lakes, trees, and animals are around for future generations. Environment aside, why save on energy? The answer is simple. You can save money. Cutting back on the amount of energy you use can reduce your energy bill significantly. With a combination of simple energy changes, you could potentially save hundreds of dollars on your energy bills this year. There is always room for energy improvement for everyone, no matter who. So guys, thank you for watching this presentation. I hope you liked it. And by the way, the answer for that question is blue, but BLEW. Got it? Haha. See you next time, guys.